The following has been developed by state and provincial agencies in association with the Agency for Instructional Technology. Together, serving education.
Have you got the sodium chloride?
Have you got the salt?
Check, boss. Have you got the H2O?
Have you got the water?
Check, boss. Have you got the tannic acid extract?
Have you got the tea?
Check, boss. Okay, we're ready. Now read what it says.
Mix together the water and the salt in the ratio of 35 to 1 grams.
Okay, so 35 grams of salt to 1 gram of water. Peanut brain, look at what it says. You see, it says, mix together the water and the salt in the ratio of 35 to 1 grams. That's 35 grams of water and 1 gram of salt.
Oh, I see. Yeah, I guess that would have been a little salty, eh, boss?
Read on.
Then combine this mixture with the dried tea in the ratio of 3 to 2 grams.
Does that mean 3 parts of this glup for 2 parts of the tea?
You're learning.
Check, boss.
Have you got the lemon?
Have you got the what?
Just testing. Have you got the sodium bicarbonate?
Have you got the baking soda?
Check. Oh. I forgot the baking soda. Excuse me.
Yes?
I'm not sure which is cheaper. Can you help me?
Sure. Let's see. All right, now this one is $1 for 300 grams. So what's the cost per gram, the ratio?
So it looks like the ratio is 1 to 3, or 1 cent for each 3 grams.
Right. Now what about the other one?
Well, that one is 50 cents for 100 grams. So it's a ratio of 1 to 2, or 1 cent for each 2 grams.
Right. So this one is 1 cent for each 3 grams, and the other one is 1 cent for each 2 grams.
I'll take this one. Thanks.
You have just seen ratios being used in 2 different ways. First, the club members were making a secret glop using specific ratios. In this case, a ratio tells you the numerical relationship that exists between 2 things, such as between water and salt. When you mix those 2 ingredients together, you must remember that the numbers are given in a certain order. When it says water to salt in a ratio of 35 to 1, the first number always refers to the first item mentioned. So 35 parts of water, milliliters, liters, etc., to 1 part of salt, and not the other way around. Or it would be kind of salty, as Bill said. In the second example, Bill went to the store to buy some more ingredients and found 2 packages with different prices, each containing different amounts. He wanted to figure out the cost per gram of each package. He did this by figuring out the ratio of cost to grams. The first package was 100 cents to 300 grams, or a ratio of 1 to 3, which is 1 cent for 3 grams. The second package was 50 cents for 100 grams, or a ratio of 1 to 2, which is 1 cent for 2 grams. Ratios can be described in different ways. For example, the kilometers per liter of gasoline a car gets. 2 out of 3 doctors recommend yearly checkups. Or for every 3 people, 1 liter of milk was consumed. These are all examples of how ratios are used in daily life.
Now we are ready for the big moment.
Add the baking soda to the mixture in the ratio of 3 to 4 grams.
So 3 parts of the baking soda to 4 parts of the glup, right?
Right,
Not the other way around.
right,
That would be pretty funny, wouldn't it?
right. Add the baking soda.
Right.
Something is definitely wrong.
You're right, Katie.
Did you say baking soda? They said baking soda.
And you got them baking powder, right?
And they're mad. Katie's unpleasant when she's mad.
Oh, okay, take this and mix it with your mixture.
In what ratio?
Oh, about 1 to 4.
1 part of this stuff to 4 parts of the glop?
That should do it.
Thanks a lot. I'd better get going. Thanks again.
Good luck.
4 parts of this stuff.
Don't be stupid. The ratio was 1 to 4, not 4 to 1.
What'd you call me, cashew breath?
Oh, excuse me, boss.
I'd say the odds on you surviving the day are about 10 to 1.
Don't you mean 1 to 10, Katie? Let's try to be a little more precise.
Bill.
20 to 1 and getting longer by the minute.
So you mean the 20 would be in my favor? That means I have 20 chances of surviving for every single chance I have for not making it.
Bill.
Just checking, Chuck. Just checking. You've got to make sure about the order with ratios, you know.
Like Bill says, you can't be too careful around ratios. First, a ratio shows how the number or amount of one thing compares to the number or amount of another. Second, the order is very important. Third, ratios can be written like this, or like this, or like this. Let's look at an example. In this fruit bowl, there are many different fruits, but there is 1 apple for every 2 oranges. Therefore, the ratio of apples to oranges is 1 to 2. Suppose in your class there were 3 boys to every 4 girls. The ratio of boys to girls would be 3 to 4, or 3 to 4. Now, also in your class, there is 1 rabbit for every 2 gerbils. The ratio of rabbits to gerbils would be 1 to 2, or 1 to 2. Let's look now at someone who uses ratios every day to keep his customers moving.
Hi, I'm Dan Brashear, engineer for Roadmaster. Bicycles are fun to ride and good exercise. They're also efficient machines, and what makes them as efficient is ratios. On this bicycle, for 1 revolution of the front sprocket, the rear wheel travels more than 1 revolution. This is because of the ratio or difference in size of the front sprocket and rear sprocket. On this bicycle, we have a 2 to 1 ratio, or 36 tooth on the front and an 18 tooth on the rear. This means for every revolution of the front sprocket, the rear sprocket and rear wheel rotates 2 times and travels a distance of 3.6 meters. On this bicycle, which is a multi-speed bicycle, when the chain is on the big sprocket, we have a ratio of 2 to 1 and the bicycle travels 4 meters. When the chain is moved to the small sprocket, we have a ratio of 6 to 1 and the bicycle travels 12 meters. Bicycles use ratios to convert your energy into more efficient use.
I think mine's the best. Don't you? It's not funny.
Yes, it is.
No, it's not. 1 to 30.
Now that's an interesting ratio, Katie.
Those are your chances of survival.
Stop that, Katie. I take it all back. Really?
very long time ago, there was a little town called Hamelin, which was ruled over by a mayor who was very mean to everyone, except to his precious cats. In fact, he loved cats so much that he had no fewer than 1,000 of them. But one year, the town was overrun by rats, who scared not only the townspeople, but all the mayor's cats as well. The mayor had to send for the famous rat catcher, the Pied Piper.
How much will you pay me for catching your rats, your worship?
The going rate for rats is 3 to 1.
$3 for one rat? That's not bad.
Little does he know that I mean 3 rats for every $1. And off went the Pied Piper to play his magic pipe and catch all the rats.
Here you are, your worship. I've caught the lot, 3,000 rats.
Very good, my man. And here is your payment, $1,000.
Huh? But that can't be right. Surely you owe me more than that.
You look after the rats, and I'll look after the ratios. Now, be off with you. But the Pied Piper was sure that he'd been cheated, so he went to ask the wife of old Farmer George about ratios.
Whenever you come across a ratio of 3 to 1 or 4 to 1 or whatever it is, you must always ask yourself, 3 what to 1 what? The mayor wanted you to think that he'd give you $3 for every 1 rat that you caught, so that when you caught 3,000 rats, he'd give you 3 times $3,000. That's $9,000. But what the mayor really meant was that for every 3 rats you caught, he'd give you $1. So that when you caught 3,000 rats, he only gave you $1,000.
When he heard this, the Pied Piper decided that he'd been cheated. So to get back at the mayor, he played his magic pipe to all the cats in Hamelin and led all 1,000 of them to a cave outside the town. Please, Mr. Piper, bring mine cats back.
Well, the going rate for cats is 10 to 1.
10 to 1. That means that for every 10 cats, I give you $1?
Oh, no. You're not going to catch the rat catcher this time. I'm talking about a ratio of $10 to 1 cat. And since there are 1,000 cats, that means you have to pay me $10,000.
Oh, very well. You win. So the Pied Piper got his money, and all the cats returned to Hamelin, and everybody lived happily ever after. Thanks to the Pied Piper being not only a good cat catcher and rat catcher, but a good ratio catcher as well.
What's up?
Gotta cut the grass, but it's out of gas.
Oh,
Wanna help?
nah. I think I heard my mom calling.
Yeah, sure.
See ya.
Yeah. Mix the gasoline and the oil in a 2 to 1 ratio. Okay. I'll put in about 2 liters of oil. And 1 liter of gasoline. That should do the trick. Something is not right here. Something is definitely not right. I wonder. Mix the gasoline and the oil in a 2 to 1 ratio. Just as I thought. Something is not right. You numbskull. Next time I should look at the ratio more carefully. It can be important.
As you can see, ratios can be fun, but they can also be tricky. So remember these 2 things. First, a ratio is used to express a relationship between numbers. And second, the order of a ratio is very important.
MathWorks is a component of the Mathematics for the 80s project and is supported in part by Exxon Education Foundation.
This program is produced by the Illinois State Board of Education under the supervision of the Agency for Instructional Technology.